So the overview of my talk will be, first I'll compare ACI and ASTM and describe the standards development process of ASTM. The reason I want to do that is because it will make you appreciate how much Doug has contributed to the standards development. And then I'll specifically list what his contributions have been, and I must recognize Scott Orthy at ASTM, who's the staff manager for Committee C09, for providing all these numbers for me that I've included in the presentation. So ASTM is an independent, not-for-profit organization formed by chemists and engineers in 1898 to develop voluntary consensus standards. And I've got this picture of a locomotive there, and that was the reason for ASTM's beginning, was that they were having a lot of failures of the railroad track because there were no standards for the steel required to make a railroad. So the organization was organized in 1898, and it was formerly known as the American Society for Testing and Materials, and it is now one of the world's largest international standards development organizations. It was founded in 1898. In 1901, the first standard on steel rails was issued. So from the beginning, it took a while to develop a standard. It's not, standards, by their very nature, in a consensus standard development process, take time. Committee C1 on cement was established in 1902, so it's one of the earlier of the ASTM committees. And C, there's a group of committees that all have Cs. They're related to construction. So C1 was the first of the construction-related committees. And in 1910, the first book of the ASTM standards came out. The book of ASTM standards is a compilation of all the active standards in any given year. And in 1914, Committee C9 was organized. In 2001, the name was changed from American Society of Testing and Materials to ASTM International, to recognize that it is no longer an American standards development organization. It has international participation and international use of the standards. So looking at ACI and ASTM, as I said, ASTM is primarily a standards development organization. It does have some training programs that are mostly associated with training on the ASTM process, and they've recently developed videos on performing some of the ASTM test methods or practices. It has about 30,000 members from 75 countries, and there are currently more than 13,000 standards. And I always tell this joke. Several years ago, one of the new committees that was developed was on cannabis standards. And every time you get in an elevator with them, they always had a lot of smiles on their face. As they were testing out some of their specifications. ACI is a technical and educational organization that develops knowledge to permit the use of concrete to its fullest potential. It used to be smaller than ASTM, but now it's actually larger than ASTM. So there's been a tremendous growth in ACI. And there are 35,000 members, over 100 countries. And I took a guess on the number of documents. I don't really know, but I'm guessing there are about 500 documents. And some of these are standards, and some are guides and reports. Now, those of us that have been in the standards world know what the difference is, but not everybody does. So let's look at what we mean by the standards development process. In ACI, the process begins at the committee level. They develop their draft, they ballot it, and once they've come to an agreement, then it goes to the TAC review, Technical Activities Committee, who checks for conformance with the format of ACI documents, and also to make sure that everything makes sense and is logical and there's no contradictions. After TAC gives approval, and the committee, well, TAC will have comments that the committee has to respond, and then TAC will approve the responses of the committee's response to the TAC review, and then it goes to this public review process where ACI makes an announcement that this document is available for public review and it's being standardized. And then the committee has to respond to any comments received from the public review, and that TAC reviews those responses, and then it goes to this final step, the standards board, who reviews the process to make sure that the standards was developed through the consensus process, that all negatives were properly addressed and everything was, above board. It's this public review process or step that distinguishes a standard from a committee report or a guide. It's the public gets an opportunity to contribute. The ASTM process is similar, but as you'll see, it's a little more complicated. In ASTM, the work begins at the subcommittee level. And then once the subcommittee agrees on a draft, it goes to a concurrent ballot of the main committee, that would be C9 in this case, and all members of ASTM. So that going out to all members of ASTM, that satisfies the public review phase. And then ASTM has what's called a Committee on Standards that reviews that the process was all done correctly. And so that the society ballot serves as that public review process or phase that's required of a standards that is done in accordance with the American National Standards Institute, ANSI. Now, what's to keep ASTM and ACI from writing conflicting standards? And this was addressed in 1936 by an agreement between ACI and ASTM, in which it was agreed that ACI would refrain from writing specifications for over-the-counter engineering materials and will concentrate on design standards and construction specifications. ASTM would refrain from writing standards related to design and construction practices and will concentrate on test methods and practices and product specifications. What's the difference between a test method and a practice? Both of them are procedures for doing something. A test method gives you a test result, whereas a practice is just a procedure, like practice for making cylinders, ASTM C31. It's a standard practice. There's no test result, but it's a standardized procedure for doing something. Now, there's an exception that was subsequently agreed to between ACI and ASTM, and that is if ACI committees require certain test methods or product specifications, and there is no ASTM committee with the expertise or interest to develop such standards, then ACI can develop a test method or a material specifications. And this is covered in those two sections shown in the technical committee manual. But eventually, ACI will give ASTM the opportunity to take on that standard and maintain it for the future. So ASCI would develop the standards initially, and then if ASTM develops or organizes a committee or a subcommittee that would be able to take over that standard, then it gets transferred to ASTM. And this happened with ACI Committee 440 on fiber-reinforced polymer reinforcement. So they developed or needed test methods and specifications for FRP bars, and they developed a series of test methods and material specifications. And those have all eventually been transferred over to Subcommittee D30.10 on composites for civil structures. So we have this agreement where we would not duplicate standards, and but ASTM would focus on the specifications and test methods, and ACI on design standards and construction standards. Okay, now I would like to go through the ASTM process in a little more detail. The reason to do this is to understand how much Doug has contributed to the development of ASTM standards. So in ASTM, things begin at the subcommittee level. So at a meeting, the subcommittee would agree that we should undertake writing a standard on some subject. And they would appoint a technical contact who would lead the effort. That technical contact would create what ASTM calls a work item, which is a way of keeping track of the process. And in creating that work item, the technical contact would write out a rationale and propose a time schedule for the work to be completed. So once that's created, then the subcommittee or the technical committee can organize a small technical contact, rather, would organize a small task group to proceed with writing the draft, and then it would go through the subcommittee ballot. Once all the negatives are resolved on the subcommittee ballot, and the ballot negative resolution in ACI and ASTM are very similar. Basically, you have to find a negative voter not persuasive for a technical reason, or you agree with the negative voter and you find them persuasive. So those are basically what we mean by resolving a negative. So once the subcommittee ballot, all the negatives are resolved, then it goes to main committee and society ballot, as we mentioned, and then any negatives received on the main and society ballot has to go back to the subcommittee for resolution. If a negative is found persuasive, then the process stops. It goes back to the subcommittee to rewrite the standard. If the subcommittee finds some negative votes on the main committee ballot not persuasive, that action has to be agreed upon by the main committee. And that's what happens when we go to ASTM meetings in December and June. That's the main objective, is to approve the actions of the subcommittees. Now, sometimes the subcommittee will find a voter not persuasive, and it goes then to the main committee for their approval, and they say, no, we disagree with you. We think the voter had a good point, and it's the non-persuasive action we don't agree with. Then it goes back to the subcommittee, starts all over again. So there's a lot of cycling can go on here, and that's the main reason why it takes time to develop an ASTM standard. But if the committee agrees with the non-persuasive action of the subcommittee, then it's approved and it goes through the procedural process and finally gets published. So why all this? To point out that the subcommittee and the technical contact are the workhorses of ASTM. So that's the ACI-ASTM. Now let's talk about what Doug has contributed to C9. So based on what Scott Orthy from ASTM provided, I've come up with this summary of Doug's involvement in C9. He joined in 1983, case you forgot. He's been a member of 12 technical subcommittees and 6 what I call administrative subcommittees that don't develop standards, but they're vital to the committee. He served as chair of 4 subcommittees and secretary of 1 subcommittee. He served on the C09 executive subcommittee. He served as secretary and chair of Committee C9, and you can kind of cut and paste and do the same thing for C1. So he has been heavily involved in the development of standards. Now, he found out that he had too much free time, so he also became editor of the Cement, Concrete and Aggregates Journal of ASTM, and he was the editor-in-chief from 1993 to 2004. And this is a letter from the editor in the June 2000 edition, in which he, as it says there, a note of appreciation for Bryant Mather. Those of you that are maybe new to the concrete world, Bryant Mather was a wonderful person. He worked at the Waterways Experiment Station in Vicksburg, Mississippi, excuse me, and Doug was reporting or summarizing the great contributions he's made to C9 on the event of his retirement from the Corps of Engineers. Okay, so I said he was chairman of several subcommittees, and these are the subcommittees he was chairman of. 966, concrete's resistance to fluid penetration. He was a chair for 10 years. Usually, or we changed it, when he started his 10-year chairmanship, that was the rule for subcommittee chairs. It was later changed to 6 years. We decided that that was a long period of time to be committed to doing all this work. So, and then he was made, he was appointed chair of Subcommittee 948 on the performance of cementitious materials and admixtures combinations, with which Larry alluded to. And he not only served for 1 term, he volunteered for a 2nd term and is now currently the chairman of that subcommittee. And then he was chairman of the 967, the resistance to the environment. And he's again taken up a brand new subcommittee, 951, on sulfate resistance, which was just created last year. He's been the technical contact for over 30 work items. So the work item, the technical contact, as I said, is the leader that keeps the process going. And I've listed here several standards that he was either the subcommittee chair, overseeing the development of the standard, or he was the technical contact that was doing all the work and resolving negatives. So C-1945. Let me say something about the numbering of standards in ASTM. The first letter, C, comes from the committee. So C9, C1, all their standards start with a C. The number is just a sequential number, and there are several ASTM committees that start with the letter C besides C1 and C9. And so as any of those committees develop a standard, it's given the next number up. So 1945 is our current highest number, and it's the newest one in Committee C9. What's the oldest? Anybody guess what the oldest standard? Think of what's the smallest standard with a C? C29. The dry rotted unit weight goes back to 1920. And C31 was also 1920 or 1922. So those are the really old standards. And they're not the same as they were back then. I mean, they're we have to revise them every 5 years. Okay, so what this new specification, you see the title is natural pozzolans. And what they've done is they've taken natural pozzolans out of C618, which used to be fly ash and natural pozzolans, then it was changed to coal ash and natural pozzolans. Well, now C618 is eventually going to be just on coal ash, and it will have the new specification on natural pozzolans. 1876 is a very important standard test method, in my opinion, that's on bulk electrical resistivity. Then there was 1827 on using, what's that thing called, the chase air meter, I think, for doing a foam index test for checking out whether cementitious materials will affect the air and training admixtures. You know, I think we all know that if you have too much coal in the fly ash, that it's going to absorb the air and training admixture. And then 1679, this is using isothermal calorimetry to check on bad interactions between admixtures and cementitious materials. C1585 on rate of absorption. C1556, another important one for determining the chloride diffusion coefficient. And then there are the two classical, I guess we call them, ASR test methods, C1293, the concrete prism, and then the C1260, the motor bar method. So just a tremendous accomplishment to be the leader in so many ASTM standards. And an example, this is that 1679 using isothermal calorimetry to look at the interactions between cementitious materials and other constituents. And those are some heat of hydration curves. So you have on the vertical axis the rate of heat evolution time on the horizontal axis, and you see that by adding or increasing the dosage of the admixture, the curves shift to the right, which is indicating that the setting time is increasing. So you can, without having to physically make specimens for determining setting time by penetration resistance, you can just use isothermal calorimetry to get the effects of different admixtures and admixture combinations on how the concrete is going to perform at the very early ages. And this is the C1556 chloride diffusion coefficient. It's probably one of the more difficult ASTM tests to carry out. I mean, conceptually, it's simple. You just soak a specimen in a salt solution, and then after a certain period of time, you grind off layers, collect the powder, and determine the chloride content in each of the layers. And then from that, you plot the chloride content versus time, and then you fit this complex-looking equation to determine the diffusion coefficient. Now, the problem is if you have a good concrete, it takes a long time to get enough penetration of chloride to be able to get a good estimate of the diffusion coefficient. So that's one of the drawbacks of the method. It gives us a very important number, but it's also time-consuming, and that's where the electrical conductivity test comes into play, because I didn't know this, but I found out that there's a direct correlation between diffusion coefficient and conductivity, electrical conductivity. So you can, in 2 minutes or less, measure the electrical conductivity and get the same information as 56 or 90 days if you're trying to do a diffusion test. So Doug has been recognized by C09 for his contributions. His first one was the Sanford E. Thompson Award. That was for, I believe it was writing one of the chapters in this STP 169 book on significance of tests, which gives the background and history of many of the ASTM test methods in Committee C09. He's made an honorary member of C09. He is a fellow of ASTM. That means he won the Award of Merit, which is the highest honor ASTM bestows. He was the Frankie Richard Award winner for his general contributions to the Committee on Standards Development. And recently he won the Catherine and Bryant Mather Member Contribution Award for the same kinds of activities. Now, he's served as chairs of several committees, C1 and C9, and he had the opportunity to give out awards. So here are some examples of Doug giving out awards. I think this might be mostly C1 folks. And I'd like to thank Scott Orthy for providing these photos. And I will conclude by making some general remarks. Research results, in my opinion, are of limited value if they do not find their way into practice. Development of new standards and updating existing standards based on the latest research is an effective means for transferring research findings to practice. Unfortunately, universities tend to give more credit to publication of papers than standards development. Doug, however, has had an excellent record in both areas. As we know, he's got a tremendous publication record, and now you've seen how much he's contributed in the standards development. So in my book, you get an A+, Doug. And this is the second time you're seeing this, but I've added, thank you, Doug. So on behalf of the old timers from Committee C9, thank you.